Waves can be fun or dramatic or even sometimes dangerous. Today we're going to look at what waves actually are and how they form. By the end of the lesson, you should know how a wave forms, you should be able to name the different parts of the wave, and you should be able to see how two different types of wave affect our coastline. Wind passing over the surface of the sea creates friction between the air and the surface of the water. This pushes particles of the water forwards, creating a swell, which is the beginnings of a wave motion. The particles of water are pushed forwards and downwards, creating a circular motion within the sea, with more particles being pulled up to fill the space between them. And there's a series of these across the ocean. The wind pushes these forwards, so the whole wave appears to move forwards, but the water actually doesn't move as the wave passes through the water. What happens is that you see the rising and falling of these circular motions, and it appears that they are travelling through the water. The wave height is the distance between the top of the wave and the bottom of the wave. And the wave length, which you might have heard of in science when studying sound or light perhaps, is the distance between the top of a wave and the top of the next one. It could equally be measured from the bottom of a wave to the bottom of the next one. The bottom of the wave is called the trough, and the top of the wave is called the crest. When a wave reaches the shoreline, it breaks. This is because the circular motions that are created in the ocean are squeezed between the rising seabed and the top of the water. As the waves approach the shoreline, there isn't room for those circular motions, and so what happens is that the water can be pushed upwards, and so out at sea a wave can appear quite low, but as it reaches the coastline it can rise up out of the water, appearing to get bigger. When those circular motions meet the seabed, the bottom of that circular motion is caught up by the seabed due to friction, and it slows the bottom down, but the wind is still pushing the top forwards. So what happens is the waves topple forwards, and that's what we call a breaker. You can see a slightly more complicated diagram here, showing you a few more terms that you might want to learn. The detail within this diagram might be useful for you later when answering the questions. There are a couple of other important phrases on this diagram: swash and backwash. The swash is the movement of a wave up the beach. It really does sound exactly like what it is, swash. The backwash is the movement of the wave back down the beach and back out to sea. There are two different types of wave. The first one we're going to look at here is the constructive wave. Constructive waves have a long wavelength and a relatively low wave height. This means that as the water approaches the beach, it runs up the beach, pushing material with it, transporting it further up the beach. These waves are quite gentle, and when they stop moving forwards, they often soak down into the beach and flow back out to sea with a very weak backwash. So the combination of a powerful swash pushing material up the beach and a weak backwash which doesn't have the power to bring much material back out to sea means that the beach is built up or constructed. We call this deposition. So a beach where there are constructive waves will get bigger. Here's another diagram showing that, with a powerful swash and a weak backwash. If we've got constructive waves, then it stands to reason that we've got destructive waves too. Destructive waves have a much shorter wavelength. These are often caused when the winds are stronger. They're much higher, their wave height is much higher, and they tend to have quite a weak swash and a very powerful backwash. These waves break and collapse down onto the beach, removing material from the beach and pulling it back out to sea. Again, we've got that in a picture. Here you can see the tall wave crashing down onto the beach. The people in front of the wave will be safe. The motion is mostly back out to sea with that powerful backwash. So as the wave crashes onto the beach, it loosens material and pulls it back out to sea. So this beach could be completely removed by these storm waves or destructive waves. So here are the tasks that you're going to do today. You can look back through this video, or you can use the PowerPoint slides from the video which I've put on Show My Homework for you. On slide 6 of the PowerPoint there's a link to another video that you might want to watch as well. So the first question, draw a quick diagram to show the anatomy of the wave, the names of the different parts. Then you're going to explain how the wind creates a wave. Next you're going to have a look at why waves topple over or break on the shoreline. Remember the word friction in your answer there. A couple of definitions for question 4 for swash and backwash. Using a diagram always makes your answer more memorable. And then you're going to create a table to look at the differences between constructive waves and destructive waves.